We will start in 5 minutes అంట. చూడు
ఎంతమంది ఉన్నారా?
17 మంది సంగ. రిజిస్ట్రేషన్ ఎంత ఉంది? వందల్లో ఉంది, వేలల్లో ఉంది. ఓ 18. ఫస్ట్ ఆఫ్ ఆల్ ఆ మెయిల్ వచ్చినా మనకేం బజర్ వచ్చినట్టు అట్లాంటి ఏమైనా పెడితే చూడచ్చు. 19 పెరుగుతుంది సంఖ్య ఒక్కొక్కటి. నువ్వా?
మళ్ళీ ఇక్కడ పెట్టి అక్కడ పెట్టి
అదే కదా అదే కదా అదే కదా. ఇంకా స్టార్ట్ చేయాలి 5 minutes అంటే. ఏంది అది ఎట్టుంది మరి? టిక్కులు టిక్కులు పడుతున్నాయి టిక్కీ. ఓహో నాకు అది చెప్పి నువ్వు ఇది వింటున్నావురా హౌల్స్. నాకు పవర్ బిఐ చెప్పి నువ్వు ఇది వింటున్నావా? టైం అనేది మార్చేసావు.
చూస్తున్నారా? ఏం మార్చారు? పవర్ బిఐ స్టార్ట్ చేయలేదురా లంజే, అసలు స్టార్ట్ చేయలేదు.
అందులో చూడు దోల తీరుతుంది అది.
స్టార్ట్
అది చూడు అసలు ఏం ఉన్నాయి.
ఎందుకు చేసిన అంటే ఎగ్జామ్స్ అసెస్మెంట్ చేసినప్పుడు ఎట్లా ఉంటుంది అని చూడడానికి కోసం అంతే.
ఎట్లుంటదంట
తెలియదు రాదే, ఒకసారి జస్ట్ అసలు ఫస్ట్ చూసి వీటి మీద క్వశ్చన్స్ ఇవే వస్తాయి కదా.
Hello everyone. Can you add me in the WhatsApp, sir? Am I audible to you guys?
Yeah, yes, audible.
Okay, perfect. Guys, on the children's using children. Okay. Okay. So, I don't know about the Telegram or the WhatsApp. It's an internal thing. You can figure it out. Someone put some tick marks. So we'll start with the week two contents, and I will start putting things here, and we will. ये बताइए तो कुछ आ देंगे ये लोग तो भी उठा देंगे
Hello, sir.
Hello. Hi. Yeah.
Sir, I'm in second year CSE department. I just started. Started a bit lately in this course.
Okay.
So I just completed my week one.
Okay.
So is there any date for submission of assignment specific?
Yeah,
Yeah,
you can check. I
I
don't know why I'm
Hello, sir.
hearing.
Wait,
But I'll check. I'm getting echoes. Hello.
हाँ voice. Okay, sir.
Yeah. So what you can do is that you can actually check the course website. That is the course
Okay.
website.
And sir,
Is,
I have just one more doubt is that I just don't know a lot of concept of probability. So from where I can learn that?
the week zero.
Sorry, sir.
There's a week zero
Week
content.
zero, yes, but
You can,
there is just a revisal point, na. So I'm not.
So that much is needed.
So we don't have to learn that in deeply.
I mean, you have to learn that, but for this course, that is fine.
Okay, sir. Okay, sir. Thanks, sir.
Yeah, I haven't added the screenshots yet, but yeah, I'll add them now and I will solve it. So if you have any doubt, meanwhile, you can put it in the chat. I'll try to solve it. Put in your doubts. Okay, so we're on the unit 2, and we'll be solving previous year questions. And someone asked about week 1's deadline. The deadline for week 1 is, I think, 7th of August. Not sure. If you go to the assignment tab, there you can check what's the deadline for the uh, then you can check what's the deadline for the assignments. And once you check the deadline there, then you have to submit the assignments before that deadline. Okay. And so what we'll be doing in this session is that we'll be picking or taking last year's assignment question. So one way to conduct this session is to summarize the week 2's content and week 2, like the corresponding week's content, and then solve some questions. But what I'll do is that I'll just solve previous year questions, and I'll discuss some concepts in between. Okay, so this is the first question that we have. Please try to solve the first questions, and I'll add other questions one by one. Someone give an answer. Yeah, you can put it in the chat. You don't have to speak up. And I'll discuss. Then I'll discuss the solutions. So one at time. Okay. So first you try, then I'll follow.
देख ले बेटा ये कहाँ है रोड पे लगा हुआ है, देख ले पहले। मतलब मैं कुछ पढ़ रहा हूँ ना, फिर दे दूंगा ना तेरे को, टीवी चला दूंगा ना नीचे, टीवी चला दूंगा। मेरी क्लास चल, ये क्लास जानते, क्लास क्या होते हैं, स्कूल जाते का क्लास क्या होती है, जानता है क्लास क्या होती है? नीचे चला दूंगा, चल टीवी चला दूंगा, क्लास चलन दो मेरी।
Please mute.
क्या लगा दूंगा ना मैं,
Please mute yourself.
लगा दूंगा मैं, सब कर दूंगा, सब कर दूंगा बेटा, मेरी क्लास चलने दो।
Okay, so we'll start solving from question number 1. There are a total of 10 questions, and we'll try to solve all the 10 questions this time because last time we couldn't. Okay, so starting from question number 1, the parameter obtained in linear regression. Then the question is can take any value in the real space. Second is strictly integers. Third is always lies in the range 0 to 1, and fourth is can take only non-zero values. So if you recall the linear regression from the lectures, so linear regression is if I draw it here, so linear regression is like in machine learning we have this x and y pair, right? So okay, so in machine learning we have this x and y pair. What we do is that we given the x, we try to predict the y, right? So in linear regression, the prediction is a linear function. That means the y equals to f of x, and f of x is linear. Come on, guys. Okay. So the regression is so linear regression is a like straight line. The reason is that in linear regression, the f of x is a straight line. The reason is that because it's linear. So we because I have muted everyone. almost. And if anyone wants to say something, you can put it in the chat. Please zoom it. It is not visible. I think it's visible. Right? So yeah, I'll solve this one, then we'll go there. Okay. So so this is linear. Linear as in so in machine learning we're trying to find a relationship between x and y. So given x, what should be the y? And the first method that we learned in the lecture is the linear regression. In linear regression, the x and y are linearly dependent. So it's not that it's linear dependent. We assume that it is linearly dependent. So let's say for a given x, there is a combination of y, and the xy pair has this point. Okay. So then we thought that, okay, we will assign a linear line for it, so that if we have a new data point here sometime in future, here, let's say, we can predict the corresponding y by finding the point in the line that corresponds with the y value. So when we are trying to find this line, so initially we will assume some line like this, then we'll adjust the line to do like this, and do like this. And at the end, we will find the optimal line. Let's say this is the optimal line that fit. The parameters are the ones that define the line. So the parameters would be M and B, C. So you might ask, like, what is M and C? So a line, so when we say like we have approximated the function, so fx here equals to mx plus a, as in a line can be represented as a multiplication of slope with the x plus a constant. So this is the constant, and this is slope. Since this constant can be anything, this can be 0, 1, 2, minus 1, minus 1.5, anything, right? And the slope can be anything. The slope can be here, anywhere. That means this will belong to any real number. So the slope and intersection will belong to any real number. That's why. So that's why the question here is asking the parameters obtained in linear regression can take any value in real space, are strictly integer, always lie in the range 0 to 1, can only take non-zero values. The answer to this question will be option 1, which is that it can take any real values. Coming to the question number 2. Suppose that we have n independent variables, x1 to xn. Mark the words independent variables, and the dependent variable is y. That means similar to here, where our x is dependent on y, here there is x1 to xn with n dimension, and the target is y. Now imagine that you are applying linear regression by fitting the best fit line using the least square error on the data. You found that the correlation x1 with y is minus 0.005. Okay. So let's talk about the second scenario. Okay. I'll just create a gap here so that better to explain things. Move this down a bit. Okay. Yeah. So here, what we have seen that here, like, there is one x and one y. Okay. But if you like think about a multi-dimensional data, so for example, like if I say for question number 1, I can say, let's say the price of house is directly proportional to size of plot, right? So that means if the size of plot is x and price of land is y, then if let's say it's linearly proportional, that means equals to k times this. Okay, linearly proportional. Then x and y, for x and y, the if x is this, the y will be something like this, right? But let's say I am working on a different scenario. Let's say I am working on a different scenario where the price of land directly proportional to a lot of more things like size of plot, location of plot, and finally, let's say we have another thing. Let's say like east corner. So this is, let's say, real, this is real, and this is Boolean. Boolean means like if it is a corner plot, it will be 1. If it is not a corner plot, it will be 0. But like is corner, right? Let's say this is also a feature. So we have 3 variables, 3x. Let's call it as x1, x2, and x3. And price of land is y. Okay. So then let's say the x1 and x2 is present. Then my x1, x2, y can be represented like this, right? And I can fit a line to represent, if this is the x1, this is the x2, then the y would be something like here. So this is x1, x2, x11, and this is y1, right? So this is the way we deal with the linear regression in high dimensional space. But since this is so 2-dimensional, we calculate it. But if it is more, if it is more than 2-dimensional, in future references will not plot it. We'll just assume it. Okay? The question that it is saying here is that saying that suppose that there are n independent variables x1 to xn, and the dependent variable is y. Now imagine that you are applying linear regression by fitting the best fit line across the using the least square error on the stack. So you have used least square error and you have found the best fit line for the regression. That means the way you said that y equal to mx plus c, here what you can say that y equals to x1 times m1 plus x2 times m2 plus up to xn times mn plus c. So this is your linear model now. So it's saying you found that the correlation of x1 and y is minus 0.005. So let's say x1 and y is minus 0.005. So this is asking regressing y on x1 mostly doesn't explain away y. Second option is y on x1 explains away y. The given data is insufficient to determine if regressing y on x1 explains away y or not. Option 4 is non-available. Can someone answer in the chat? Can someone try to answer in the chat? Yeah, repeat the question. So the question is question number 2 only. I explained the questions and then I'm trying to ask which of the 4 option is correct. people are saying option A is correct. Does not explain anything. So dependence of variable. Okay. So if you know, like, if let's say, like, let's say you're trying to find the price of a land, and you say that, like, you try to find, like, if the location of the plot is a valid thing to like, take care while considering or while buying a plot or not. So for that, what you do is that we find the correlation of a variable or a factor towards the pricing or the target. And here, as you can see, the correlation is minus 0.00. So if the correlation is let's say, if correlation is close to 1, that implies positive correlation. That means if the price, if that variable increase, the target variable y or the price also increase. If it is close to -1, if it is close to -1, that means it's negatively correlated. That means if this value will increase, the target value will decrease. And third thing is, if it is close to 0, that means uncorrelated. That means if this value increase or decrease, that will not affect the y. So regressing y on Excel mostly doesn't explain away y. That means if I change the value of x1, the value of y will not be changed. So if I explain that graphically, it will be like graphically. So it will be like, so let me plot. So let's say it is x1 and it is y. Can someone answer, like, which among the following would be the correct plot for x1 and y, given that it is very low, minus 0.001. So will this, so will this be the x1, like, actual line, or will this be the actual line? Sorry, will this be the actual line? So which one would be the actual line, red or green, for x1 and y in this case? Can someone try to tell? In this case, what would be the? So you said that x1 is almost not correlated to y, and since the correlation is very close to 0, that is 0.000 minus 0.005, and so, like, what do you think? Like, is this so if I have to plot x1 and y, which is the approximate line? So since the correlation is almost zero, that means if I change x, there will be very little change in y. That means if I change the x from value of x from this point to this point, the change in y should be very less. That means the change in value of y should be less. That means the value of here and here would be very less. So that's why green one would be the correct representation for this correlation 0.005 minus 0.005. Okay. And if you take the red one, value of y is here like this, but here is like this. So there's a huge change in the value of y. This much change. That means it is not that variable. Okay. Then coming to the question number 3, I think question number 3. The relation between studying time in hours and grade on the final examination in a random sample of students in the introduction to machine learning class is found to be this. So see, like every time we'll solve a problem, it will be like there will be some input, there will be some input variables and there will be some target variables, right? And the input variables will be deciding the value of target variables, right? And which input variable to use will depend on this correlation of the variables. Okay? So it's saying that the final grade of an exam is depend on 30.5 plus 15.2 into number of hours you have studied. Let's say the grade is decided by this. Okay? It's asking how will a student's grade be affected if she studies for 4 hours compared to not studying. It's a very simple question. It's not including any machine learning. So, so could everyone try at least first to solve this? And yeah. Sorry, I was on mute. I didn't know that. Sorry. Yes, so did I explain this question with audio or without audio? The great question. So from where did you stopped hearing the audio? Right? Virendra Kumar. So Virendra, could you please tell like from which question did I mute the audio? Okay, after question number 3, you didn't share. Okay, so did I explain the third question or is it was I on mute? Okay, third was explained. Fine. So after third, I copy pasted the fourth question. Okay, and so what I was telling is that are these questions same as this year's question or is it different from this year's question? Because I should not be discussing this year's question. And sorry for muting in between because some people when they are joining, they're trying to shout. So I'm just putting everyone on mute. Since I'm joining from the different devices, I think I put myself on mute as well in this device. So that might have resulted in this. Anyway, so we will discuss the question number 4, that is, which is like two variables x and y, and one is like so one variable is -1, like x and y. So we want to learn a function. So as I said, like there will always be learning a function because in machine learning we try to approximate a function, and so we are trying to learn the function, and in this function we will try to. So the parameters of the functions are a and b. Okay, and the what we're trying to do is that we're trying to use the squared loss function, and we're trying to find out which of the following 4 parameters, which of the following 4 parameters is suitable for our this will perfectly fit this x and y. So if you could start solving it, I'll discuss it in 2 minutes. Okay. So sorry, I was I hope I'm audible. So will you give the recording of this class to us and the last class as well, please? Yeah. So if you go to the YouTube channel, it's already uploaded. The class was already uploaded there for the previous one, and for this one, I will upload it by tonight or tomorrow. We only be discussing these quiz questions today, sir. Yes, sir. We feel discussion is going deadly slow. Yes, sir. Don't we? Either we can't hear when you speak, or we feel like we are sitting idle. Okay, sir. Thanks. Don't know whether we can hear. Yeah, no. So I'm giving some time to solve the questions. So if you cannot solve the question, just say that okay, we cannot solve these questions. So you can try explaining those things. Okay. I can. I can go first. Okay, I can go first. The reason I'm going slow is that this course is new for you, and you might not be able to understand everything. I feel the questions are pretty simple. No need to wait for these questions. Okay. No. So did you get the answer for question number 4? Because a lot of people are not answering, so that is making me like unsure that if it is a good time to go forward or like just stay. But anyway, so what you have to do is that I'll explain the question and try to go first. Okay. And yeah, I'll try to go first and I'll see what is happening. Okay. So it's saying that so if I try to find the approximate, so try to find the solution which gives the least error. So when we try to find the line that fits all these like all these variables and all these data points, we try to find the best line, right? So how to find the best line? So question is how to decide the best line. So one answer is the mean square error. So we'll take all the lines and we'll try to find the mean square error from all the points, and the line having the least mean square error will be the best line. Okay. So what you have to, the exercise here is that you take one point like 1 so that means your f of x will be your f of x would be x plus 1. Okay. And because a and b is 1, will be x plus 1. And for this, what you do is that you try your value of x. So if you put value of x equal to -1, y equal to will be 0. So if x equals to -1, second value is if x equal to 0, y will be 1. And third value is if x equal to 1, y would be 2. And fourth value is if x equals to 2, y would be 2 plus 1, 3. Okay. So these are the y that you got, but there is some actual y, right? 0.0319, and second one is 0.8692, and third one is 1.9566, and fourth is 0.0343. So what you do is that you take the mean square error between these two, all this value, and the way you calculate that is, so your loss would be 0 minus 0.319 square plus 0.8692, 1 minus 0. Square, and similarly. Okay. So you calculate this, all this, and you take the square root. square root, and you will find a value that will be value 1, let's say. Okay. Similarly, again you will put 1 and 2, and you'll get value v2. And similarly, we will get v3 and v4 for all the 4 options. Then we will find the least among these. So after finding the least value among these 4 values, you'll be able to find the best fit. That means the value of A and B that will give the least error when you insert them. So if you do all this math, you'll get that V1 has the least error, and that will make this 1 and 1 as a solution. Okay. I'll try to get the next question. Next question is here. The next question is consider a modified k nearest neighbor. Consider a modified k nearest neighbor method in which once the k nearest neighbor to the query point are identified, once the k nearest neighbor to the query point are identified, you do a linear regression fit on them and output the fitted value for the query point. Which of the following is true regarding this method? This method takes an assumption that data is locally linear. Second, in order to perform well, this method would need dense distributed training data. Third is this method has higher bias compared to k nearest neighbor. Fourth is this method has higher variance compared to k nearest neighbor. So you try to solve this question, and I'll give you 2 minutes this time, not much. So since people are saying that it is going very slow, so we'll discuss the question of 7.5. Okay. So the question is saying that Do you recall k nearest neighbors? So if you have done the lectures, so k nearest neighbor is like there is a group of points. And let's say you want to classify this as 3 clusters. So that means k equals to 3. Okay. So let's say this one is this and one is this, the 3 clusters. And these are also neighbors, nearest neighbors here. Okay. So what it is saying is that in this hypothetical method, so how the centers are like design is that like you take a center and you find the k nearest neighbor around it. So what is saying that let's say like you want to decide this and there are like let's say 5 points that you have like 5 nearest neighbors from the center point you have identified. Now, so this by the center point is decided by taking a mean on this. So the way we calculate the mean is that you summation of I equals to let's say 1 to 5 by 5. So this is typically calculated using the mean. But since we are using the regression now, so the question framer is saying that let's say instead of deciding by this, let's say we decide it by this. So let's say we decide it by y equals to x1 a1 plus x2 a2 plus x3 a3 up to x5 a5 plus a0. Okay, so let's say we decide the value of y or the center yc, let's say call it yc as this. Okay, so if we do like this, we have to get a training data and train it and all these things. So the question is that does this method assumes local linearity? So option number A is that does it assume local linearity? The answer is yes. The answer is yes, because so we are assuming that the center point is linearly dependent on the center point is linearly dependent on all the data. So A is correct. Since we're assuming the linear dependence, locally linear, then only we are expressing y as a sum of linear function. Then option number B is, in order to perform well, this method would need dense distributed training data. The answer is yes. The answer is yes, because if we have sparse data, the data would be very far away from the center. Okay, and the notion of local linearity, so this local linearity will not hold. So to make it hold against the local linearity, we also make the option B correct. Then option C is, this method has a higher bias, and option D is, this method has a higher variance. Out of this C and D, one will be correct, because as we know, bias and variance are opposite. So if one is more, the second cannot be more. Okay, it's like contradicting. So then what you can say that so as we know, so now apart from all the parameters that this k nearest neighbor had earlier, we have added a1, a2, a3 up to a5 and a0. That means we have increased the number of variables. That means the variance has increased. Okay, so option D would be correct, and that's why option C will not be correct. Okay, so we have increased the variance by introducing lot more parameters. So once we increase the parameters, it will increase the variance. Variance means a small change in data will will cause a large change in the output. So the more it is like spread out across different parameters, this will happen. That means if you change the value a small amount, the output or the y would be affected by a large amount. Okay, so that was question 5 for you. Then let's go to the question 6. Question 6 is pretty simple. Okay. Question is, which of the statement is that true? The Reese has a sparsity constant while and it will drive coefficient with low values to 0. Second is lasso has this closed form solution for optimization problem, but it's not the case for Rich. Third is Rich regression may reduce the number of variables. Fourth is if there are 2 or more highly collinear variables, lasso will select one of them randomly. So this is like multiple choice question. So you can try solving it. Yeah, we can try. So you can try solving it by one. Like just choose the number. Which of the following is correct? So it was directly from the lecture. So it's not like rocket science here. So just if you haven't seen the lecture, just go see what's the lecture and you'll get the answers to this directly. So I'll wait for 1 minute before discussing this. Okay, so answer is C and D. Okay. So Ridge and lasso are like type of regression. So there is least regression and lasso regression, and they have a different loss function. Also, they also use a different what do you call it? They also use some so I forgot the exact term that they use. So that will not allow the like some parameters to grow exponentially or like lose value exponentially. That's called yeah, I forgot the exact term for that, but yeah, so they use that to make the regression model more robust. So that's why like regression may reduce the number of variables, and if there are 2 or more collinear variables, lasso will select one of them randomly. So like if there is x1 and x2 and x1 and x2 equally affect y, then lasso regression will take x1 and make decision on one variable rather than giving importance to both the variables. Coming to the question number 7. So these are all like introduction, like theoretical things, but it will be beneficial once you try to solve your machine learning problems in real world. So you can actually like take use of these facts that okay, so if this is the case, I should be using regression, and if this is the case, I should be using clustering, or if the data set is more biased, or like the number of parameters, how they affect the biasness and everything else, you can make use of this. Work on the question number 7. Choose the correct options from the following. When working with a small data set, one should prefer low bias or high variance classifier over high bias low variance classifier, and yeah, and so on. So like there are 4 options. So if you have understood the concept of variance and bias, so you should be able to answer this question. Okay. So, so I don't know if you have understood the concept of bias and variance. So bias means, let's say, you have a cat and dog classifier. So this is a very interesting concept. You try to grasp it now. So let's say like you are training a cat and dog classifier, and you got like, so you got 1,000 picture of cat, and you got, let's say, 1,000 picture of dogs, and you got 1,000 picture of dogs from, let's say, 100 breeds. Okay. And let's say from the cat picture, you got 500, also you got 500 from your cat, let's say cat 1, and another 500 pictures for cat number 2. Let's say it's a neighbor cat, right? So the problem with this, and you try to train a machine learning model to get a cat versus dog classifier. Okay. The problem with this setting is that the variance in the data set for cat is very low. That means the way the data varies in the cat for the cat is very low. Okay. So, but yeah, so variance is very low. That means the model will be biased towards class 1 and class 2. So you must have heard about biased coin and unbiased coins. So in biased coin, like there will be a lot more number of one head or tail as compared to the unbiased coin, but the head and tail proportion will be 50 and 50. That means if you train an ML model with this, the machine learning model will only be able to classify the cats from your cat and your neighbor's cat. It will not be able to classify some new cat, let's say cat 3, that it has never seen. So what you want to, so it's like training a human baby. When you are trying to train a human baby, you have to So them different pictures of cat so that they can know that okay, this is a cat. But yeah, so like ML model needs variety of examples for cat to know that okay, this is the like one of the patterns for cat. So if you give them cat like of just 2 class, the bias will be very high. That means it will not see different varieties of cat. So it will be fixed towards this cat 1 and cat 2. And if you give it a different breed of cat, it will not be able to understand it and it will not be able to classify it properly. But if you, in case of dogs, since you have provided with 100 breeds and you have given it like 10 dogs from each breed, the model will be able to get a very good understanding of the variance or like how the dog vary from each other and the entire family of dog, how they're the commonality between the entire family of dogs. So coming back to the question, when working with a small data set, so if you have let's say small data set, let's say we have in total of 100 data, one should prefer low bias, high variance classifier over the high bias and low variance classifier. So when the data is small amount, we don't want. So if the data is small amount, we don't want we don't. Yeah, we don't want bias. We want sorry. Yeah, so we don't want the variance because if we change, so in small data set, variance is a concern because since even small changes in the training set may change the optimal parameters significantly. That means if I have a small data set and let's say like there are like 10 pictures of 50 pictures of cat, if I if I do a change in the training data set, it may change the optimal parameter significantly. Hence, the high bias, hence the low bias and the high variance is not preferred in a low data set. So in a smaller data set. So hence option B would be correct. And that is like for small data set, we should prefer high bias and low variance. That means if there is like 10 pictures of cat, we want like the variance is not that high, it is fine, but the bias should be higher. And the opposite in the larger data set. In the larger data set, we prefer that we have the significant point to represent the data distribution accurately. Hence, even if the variance is low, it's fine because we'll be able to represent the entire data by some or other points. But we need high variance. Yeah. So the option D will be correct for the large data set. Low variance and low bias and high variance over high bias and low variance. So the options are a bit confusing. It's just 4 different things written here and there. Coming to the question number 8. Meanwhile, I'll post. You try to see the question number 8. I'll post the question number 9 as well. And question number 9 is the last question in our discussion today because assignment last year was 9 question. Okay, statement A, in forward stepwise selection, in each step, the variable is chosen which has the maximum correlation with the residual. Then residual is regressed on that variable and it is added to the predictor. Statement B, in forward stage-wise selection, the variable was added one by one to the previously selected variables to produce the best fit till then. It's an easy question. So it's a question from the feature selection where we select the feature which are important to the classifier, which are important to decide the correct value of y. The way we select is that like one is forward selection, one is backward selection, and it is the question is uh, like about the forward selection, forward stepwise selection, where it's asking that in forward selection, statement A is that variable is chosen which has the maximum correlation with the residual, and then the residual is regressed on that variable and is added to the predictor. Second is variable are added one by one to the previously selected variable to produce the best fit till then. I'll tell the answer. Both the statements are incorrect because we never execute the regression methods. Yeah, both are false. What's the final answer to question 7? B and D. Yeah. Question number 7 is B and D. Okay. So question number 8, both are false because we never predict things while we are selecting. We just select and at the end we predict. And that's a different method. So you can refer to the lecture for this. You'll get the best answer from there. Not a great question to discuss, by the way. So come to the final question, the 9th question. The linear regression model y equals to a0 plus a1 x1 plus a2 x2 up to ap xp is to be fitted to a set of n training data points having p attributes each. That means we have a data set here. We have like x1, x2, xp, and we have like 1 to p. Sorry, 1 to n having p attributes each. Let x be n times p plus 1 yp plus 1. Okay, vector of input values augmented by ones. Yb, so this is x, and this y equals to n cross 1. Okay, vector of target values, and theta b p plus 1 into 1. So the reason we put p plus 1 not p is that we are also considering this one a0. Okay, vector of parameter values a0 to ap. This is a dimension. Okay, if the sum of square error is minimized for obtaining the optimal regression model, which of the following equation holds? Okay, so this is just you're like the equation that you got while solving the parametric form of the this equation. So the matrix form of the linear regression. So I'll solve it. So it's a bit tricky, but yeah. So you can find it in the lectures solution as well, in the lecture as well. So sum square error is used to minimize the thing. So when the sum square error is used, so the loss is mostly like so the loss would be, or sum square error, mean square error. So in matrix form it is written. So the correct is y minus x transpose theta and y minus. So I'll explain what this is. So like when you decide y equals to x theta, right? So so earlier we wrote y equals to mx plus c, or we have also written y equals to a0 plus x1 plus x1 to a1. So we can also modify this. It will be equivalent to a0 x0 plus a1 x1, and we'll put this x0 value as 1. It will be similar to that one. So if I put this, so that will be similar to y equals to summation of ai xi I equals to 1 to I equals to 0 to 1. Or what I can do is that I can combine this and I can say that y equals to x theta. Okay. So if y equals to x theta, what is my loss? Loss would be y minus x theta, right? What is my square loss? Y minus x theta square, right? So if I have to find, like, write it in the matrix form and find the matrix equivalent, this square would be y minus x theta times y minus x theta. Since it is matrix, we have to take care of the dimensions, like the multiplication criteria as well. That's why we put transpose here on top of theta as well. So this is the loss, and it is coming from here. It's not the exact, like, comeback or exact transition, but it is the similar. Okay, and this is in the matrix form. This is called the matrix form. Okay, and if we take the derivative and equate to, so we have to minimize the loss. So in machine learning training, we minimize the loss. So when we minimize the loss, we put the things to 0, like, this. We put the things to 0. Like, if you recall, how do we minimize in the derivative? What you do is that you put the y, like, equation to 0, and you try to find the value, right? So if you equate it to 0, you'll get x transpose y minus x theta will be 0. That will imply x transpose x theta minus x transpose y will be 0. Like, we just expanded it. Okay. And that will imply x transpose x theta will be equals to x transpose y. That will imply x transpose x theta would be equals to x transpose x inverse x transpose y. So sorry. So you take this and you put that as first. Okay. So that implies theta will be equals to x transpose x inverse x transpose y. So we are asked you to find the optimal regression model or the parameters. So yeah, I think we found the solution. We don't need to find the theta here. So solution is D x transpose x theta equals to x transpose y. Okay, this is solution. We moved a bit forward. This is solution. Okay. And you obtain this by taking the loss function and making it 0. Okay. Does anyone have any questions? No? Okay, okay, perfect. Okay. And which channel is the recording posted? Please someone ping it again. I'll be able to. One second. Okay, so I'll ping the channel. Once again. Yeah, so I pinged the channel. You can join the channel, and I'll be posting this video as well. Okay, so we'll close the session now, and we'll meet next week. So let me know, like, if I have to discuss some of the like course content as well before starting with the questions, or should I just start with the questions? So just let me know about that, and that is fine. Okay, thank you.